So this question says a circle is circumscribed around a square. So first of all, that's describing something that can be drawn. So that makes it a plug-in picture question. So we use this strategy for any question that describes something that can be drawn. So a circle circumscribed around a square means, first of all, I have a square. So you go to your scratch paper, draw that square, and then the circle goes around that square. And to be circumscribed means that the circle touches every vertex of the square. So I'm not concerned about my circle or my square, really, for that matter, being perfect, but at least I have a visual now to work with. The next sentence says the side length of the square is 14 inches. So the second part to plug in picture after drawing is to label. So I know that each of these sides are 14, so I'm going to just call each one of them 14. Then it says, what is the radius in inches of the circle? So the radius of the circle can be drawn really anywhere I'd like from the center of the circle. But given that the question provided a square, the best place to draw a radius is going to be to one of the corners. So I'm going to choose this corner here, but you could have chosen any corner you wanted, right? So it's better to draw the radius there than to draw it anywhere else. So now I want to find that radius, so I call that R. I don't know what that is. These 14s don't really help. But if I were to extend this line to a diameter, this is going to be very helpful. Let me show you why. Because now I've turned the square into two triangles. So I'm going to draw that triangle here. In fact, I'm going to draw half of that triangle, which I know is a right triangle because I have a square. I know this is 14. I know this is 14. I don't know what this is. Now, this right triangle is a special type of right triangle. It's a right triangle that you will see on your formula sheet that's provided for you on the digital SAT that you can just click on and reference it at any point in time. What you'll see there is that you have a triangle like this that says x, x, and x square root 2. This is a 45, 45, 90 triangle. And what this shows us is that whenever we have a right triangle with two sides that are the same, the hypotenuse is always the length of the side times square root 2. So that means I can erase this x here and say I actually know that this hypotenuse, or this long side of the right triangle, is 14 square root 2. And then if I want the radius, which again is just half of that line, I just have to divide that by 2, right? So 14 square root 2 is the diameter. Half of that would be 2 goes into itself once, 2 goes into 14 7 times. So the radius here would be 7 square root 2. So that is the answer to this question. So this is useful to know. So keep that in mind, that those special right triangles are on your formula sheet. If you did not know that, you could have also used Pythagorean theorem, which is also on your formula sheet, in which case we would have said 14 squared plus 14 squared equals c squared, right? Just, again, pretending like, we're acting as if we did not know this side, and we called it side C as the hypotenuse of a right triangle. And then from there, we would have found the same answer, really. We would have found that this is going to be 14 root 2. When you do that. So either way, both strategies work. I prefer just knowing the right triangle way because it's the fastest, but Pythagorean theorem also works. Let me just continue the Pythagorean theorem for you so you can see that it works. So 14 squared is equal to 196. So it becomes 196 plus 196 equals c squared. 196 plus 196 is 392. So we have 392 equals c squared. And now I want c, right? So I need to take the square root of both sides. The square root of 392 is going to be 19.79 and some more numbers after that. That gives me the c value. And if I go to my graphing calculator, if I go to Desmos, I can type in 7 root 2 to see if that matches. Clear this out. So if I say 7, that is going to equal, actually, it's going to equal half of it, right? So I want this to be half of this. Let me not forget, I divide this by 2 first, and then that's how I'm going to get 9.899, and that value is the same as 7 root 2. It's the decimal form of 7 root 2. So hopefully that makes sense. Everything started off with, first of all, drawing. Second of all, labeling those 14s. Third, really knowing how to draw the radius, so knowing where to place it, that it's best to place that in the corners. And that really comes by learning from a video like this, learning by doing, because otherwise you may not have known to draw the radius to the corner. And then knowing to extend that radius to a full diameter so that we have a right triangle. And then recognizing that this right triangle has 2 of the same sides, making it an isosceles right triangle, which means we then know this information here about the x root 2, which then tells us that our whole diameter was 14 root 2. And then, of course, because we want the radius, we're dividing by 2, which is how we get the 7 root 2 as an answer. So hopefully that all makes sense.